So in this video we're going to look at resistors in series and Kirchoffs Voltage Law. So in a series circuit, what we mean by series is that these are resistors, and resistors restrict current flow. So these could be represent a load such as a lamp, or in electronics we can use resistors in series to divide the voltage by what we call a voltage divider. So a couple of rules to understand in a series circuit then is the voltage in a series circuit drops across each load, or each resistance if you like. So in this particular circuit we're going to get three voltages, okay, like so. So the supply voltage, and we could call that Vs, which is V supply, is 24 volts. So Kirchoffs Voltage Law states that the sum of the voltages equals the supply. So Vs is V1 plus V2 plus V3. So what that means is the volt drop. So if we were to get a voltmeter, so that's going to be the plus side, because it's on the battery. The plus side is the longest side. So the conventional current flow, not the electron flow, but the conventional current flow is going to flow clockwise. So what a lot of people trip up on with series circuits is that they think that the 24 volts here at the supply is 24 volts across each resistor. Well, that's incorrect. What happens is the voltage drops each time, and as a rule, if we look at Ohm's law, so Ohm's law states that the voltage is the current flowing through the resistor times the resistor value. Okay, so in theory then, the bigger the resistance, the bigger the voltage would be. Yeah, so if you look at the ratio here, you've got a 20 and a 50. So, sorry, I beg your pardon, the 20 and the 30, so that's 50. So if you, obviously these two added together, so between there and there, we've got, I'll just put the ohms figure on there, let's do things properly so it's clear. So we've got 50 ohms here, across there like that. So now, you've got 24 volts, so because they're an equal resistance between these two, you are going to get 12 volts, just change the pen, that's going to be 12 volts there, right? 12 volts across that resistor, and then you will get 12 volts shared between these two, okay? Not individually, but both combined. So we can look at a ratio then basically, so obviously it's 20 to 30. So you can work it out using a ratio, but what I like to do is I go a little bit around the houses a little bit with this. So applying that theory onto there, if we look at V3 now, we can work out, well, we know V3 is 12 volts, we can work out the current I. Now in a series circuit, I is the same for each resistor. It doesn't change throughout. So that value I that flows through those resistors will be the same value. So if we've got 12 volts across V3, then using the Ohm's law triangle, so V here, yeah, we're going to find out the current I, so it's P over R. So to work out the current flowing through the 50 ohm resistor, so we could call that R3. So just for labelling purposes, R3, R2, R1. So each resistor's got an identification. We can work out the current now. So if we look at this resistor, the 50 ohm, so that's going to be 12 volts over 50. So if we divide, get the old calculator out, so 12 over 50 gives us 0.24. So that effectively means, that's incorrect there, so that's 0.24 amps. So in our circuit we have 0.24 amperes that will flow right the way through each resistor. So to work out now we know what the current is through each resistor, then we can simply apply Ohm's law. So V2, that's going to be 0.24 times 30. Okay, so get the old calculator out again. So 0.24 times 30 gives us 7.2. So we're going to get 7.2 volts across that particular resistor. So if you think about it, so we've got 7.2 volts here, V2. We've got 12 volts here. Okay, so what that means basically is if we add them two together, that comes to 19.2 volts. Yeah. So whatever's left will be flowing through V1. Okay, and we can do a check afterwards. So V1, apply Ohm's law. So I times R1. Gets a bit laborious writing the formula out, but it's good practice because it helps you remember. I've done this probably thousands of times over the years now. So 0.24 amps times 20. So obviously 0.24 times 20, well that's going to effectively become 4.8. So that's 4.8, try and write that into there. 4.8 volts. So you've got 4.8 volts at V1. So in theory now, as a check, so let's prove this, the Kirchoffs Voltage Law there. Put a box on there because that's quite an important one. So 24 volts should equal 4.8 volts for V1 plus 7.2 volts for V2 plus 12 volts for 3.3. If we add all those up there, indeed 2, 5, 7, we get 24 volts. So another thing with this, we could work out the total resistance of the circuit just to prove. So one way, if you're doing homework, you know, to prove your answers, how do you know your answers are right? Well, I'm going to call that V supply over the total current. So to work out the total resistance there, this should work. So 24 divided by 0.24. So 24 divided by 0.24 should give us 100 ohms, which it does indeed. Okay, so if you add all those resistors together, 20, 30, 50, we get 100 ohms. So these values must be right. Moving on a little bit further, the total power of the circuit, so total power. So there's different power formulas. For the total power of the circuit, then it's the current times the total voltage for the total power. So that's going to be 0.24 times 1, sorry, beg your pardon, not 100. So VS 0.24 times 24. So 0.24. And that gives us 5. So that gives a total power output of 5.76 watts. Okay, that's the total power of that circuit. If you wanted to work out the, let's just say we wanted to work out the power rating. So the power rating of the 20 ohm resistor. Then we could use a multitude of formulas. We could use V squared over R, or we could use I squared R, which is a little bit more popular, or common should I say. So using the I squared R, I squared times R, that's going to be 0.24 squared, because that's the total current flowing through the 20 ohm resistor, times the resistor value itself. So that means the power rating of the 20 ohm resistor P20 is 0.24 squared times 20, which means it's 1.15 watts. Yeah, and you can do that for the same and just to prove obviously the V squared over R. So for the P20, if you wanted to do the V squared over R, then obviously the voltage is, so that's 4.8 squared divided by 20, and that should give us 4.8 squared divided by 20, 1.1 watts, exactly the same. So, okay, so that's a series circuit. Resistors in series and a little bit of Kirchoffs and Ohms law and rounded up. Another formula for your resistors in series, total resistance, you just add the resistors together, so R1 plus R2 plus R3, etc. Remember that in a series circuit the current is the same through each resistor, but the voltage drops. So if we redraw this out, if this was an electronic circuit like we have here, we've got 20 ohms, 30 ohms, so we have 3 resistors in series. In an electronic circuit we would have multiple voltages, so you would have 4.8 volts between here and here, you would have 7.2 volts between there, and 12 volts. So you've got 3 different voltages there to tap off from in an electronic circuit, and that's known as a potential divider, because you are dividing the total supply voltage by obviously over 3 values. If all the resistors were the same value, then you would get equal voltages. The higher the resistance, the higher the volt drop. Okay, so that pretty much concludes resistors in series at this stage. The next video we'll look at parallel, and then we'll carry on and do a few more exercises as well. Hope you found this useful. Thanks for watching. Click like and obviously subscribe. Cheers.